Good morning, class. This is the second time I've recorded myself doing this. The first time the microphone was off. All right, so this is 4.4 determinative forms and LHospitals Rule. Actually, it's spelled hospital, but I've always heard it pronounced LHospitals. So it's 4.7 CED, that's course exam description, which is using LHospitals Rule for determining limits. The idea here is that when you cannot use the tricks we learned in Chapter 2, for example, like this one, if you want to find the limit as x goes to 1 of ln of x over x minus 1, you can't use the techniques that we learned, which was basically algebra, using algebraic tricks. We can't use that because there's no real algebraic trick we can use for ln of x over x minus 1. So LHospital came up with the realization that when you do have the indeterminate form, remember that's the golden rule. If you get 0 over 0, which is the main one we see, but it also works with infinity over infinity, that if you come across this, you could just do the ratio of the derivatives. That's right. The LHospital rule states that if the limit as x goes to infinity of f of x over g of x will equal the limit as x goes to a of f prime over g prime if it's of the indeterminate form, 0 over 0 or infinity over infinity. And in words, it's the limit, I'm reading this, it's the limit of a quotient of functions is equal to the limit of the quotient of the derivatives. So when you're given this, limit as x goes to 1 of ln of x over x minus 1, do direct substitution. You always try that first. If you put ones in top and bottom, you end up with 0 over 0, which is indeterminate. So that means we can use LHospitals rule, which is you take the derivative of the top, and the derivative of ln of x is 1 over x, and the derivative of the bottom. Derivative of x minus 1 is 1. And you can now use direct substitution, you get 1. Okay? So the limit as x goes to 1 of ln of x over x minus 1 is equal to 1. And we can see this graphically here. Here's the graph, if you're wondering. That's the graph of ln of x over x minus 1. And as you see, and I can't really highlight, but I'll blow it up, as we approach 1 from both sides, the graph appears to pass through y equals 1. So, but if we were to really focus in, it'll say it's undefined there. It'll say not defined. But as you can see, the graph appears from both sides to go to 1, the output. Thus, the limit as x approaches 1 of ln of x over x minus 1 is equal to 1. And we saw that by using the LHospitals rule by looking at the ratio of its derivatives of the top and the bottom. Let's try example 2. The limit as x goes to infinity of x squared minus 1 over 2x squared plus 1. Now, if you remember your time in math analysis, or even in advanced algebra when we were talking about rational functions, you would remember that if it's a rational function, which means it's a ratio of polynomials, all you have to do if you want to look at limits at infinity is to look at the ratio of the lead terms. So in this case, it's x squared over 2x squared, and that does indeed give you 1/2. But LHospitals will also give you that same answer. Because if you take the derivative of x squared minus 1, you get 2x. And if you take the derivative of 2x squared plus 1, you get 4x, right? And the x's divide out, and it leaves you with 1/2, 2 over 4, which is 1/2. Okay, now example 3 is an example of one that you cannot use the stuff you learned in math analysis or advanced algebra because it's not a rational function. It's just a ratio of e to the x over x squared now as x goes to infinity. As x goes to infinity, the top will go to infinity and the bottom goes to infinity. So we can use the LHospitals rule. So we take the derivative of e to the x, which you should know is e to the x, right? That's the reason why e to the x is so important. The derivative is equal to itself. And then the derivative of x squared is equal to 2x. Okay? Well, that's still infinity over infinity if you plug in the infinity into the x on top and bottom. So we can do LHospitals Rule again. And we still get e to the x on top, and we get 2 on bottom. So now we can do direct substitution. You end up with infinity over 2, which is just infinity. And that's the limit of e to the x over x squared. All right. Example 4, which is the last example. I just wanted to point out that when you're talking about exponentials, and you're looking at an exponential over a rational function, exponentials will always blow up or go to 0 faster than the polynomial. It always is the case, and you can see it here. If it's a ratio of an exponential over a polynomial, right? The x squared is a monomial, but it's a polynomial. If you use LHospitals repeatedly, e to the x stays the same, but you'll end up with just a number on bottom. I don't know what that number would be, depending upon the polynomial you have, still over e to the x. And if we're looking at it as it goes to infinity, it will still go to infinity. That kind of shows you that in functions, e to the x is an exponential, in this case e to the x, will always blow up at the extremes faster than a polynomial. It could be x to the 200th power. And if you keep using LHospitals, you'll end up with just some number at the bottom on top of e to the x, in which case it still goes to infinity. All right? All right, so let's look at the last one, ln of x over the square root of x as x goes to infinity. All right? Well, you have to remember something. If you plug in infinity on top, you get infinity. And if you plug in infinity on bottom, you get infinity. So it matches the indeterminate form, infinity over infinity. So now you have to remember, we take the derivative of the top. Derivative of ln of x is 1 over x. And the derivative of the square root of x is just 1 over 2 square root of x. Now, if you're wondering how I got this so quick, because I know you have to have this memorized, really. You have to know the derivative of the square root of x is 1 over 2 square root of x, because square roots show up all the time, okay, all the time when we're dealing with this stuff, especially at this level. So just to remind you how I got this 1 over 2 square root of x, it's a simple power rule. I remember that square root of x is simply x to the 1/2 power. So using the power rule on that, you end up with 1/2 x to the 1/2 minus 1. 1/2 minus 1 is x to the negative 1/2. And x to the negative 1/2 means the x drops down and the 1/2 turns into the square root. So that's how we got this. So the derivative of the square root of x is 1 over 2 square root of x. All right, so we can go from here to here. Now the rest is algebra, right? 1 over x over 1 over 2 square root of x. Okay, I did it one way. You could also have reciprocated this and gotten the same idea. You end up with basically that. 2 over the square root of x. All right, that x and cancels out with that x into a sense, right? This square root of x and underneath x gives you x to the 1/2 on top. That's how I got this. And then I flipped it upside down to get this. And now we can use direct substitution. We can plug infinity in. 2 divided by the square root of infinity is 0. And thus, the limit as x goes to infinity of ln of x over the square root of x is 0. All right. This is your homework. All right, we'll collect this on, it will be due on Sunday, this coming Sunday. But if you have until Wednesday to get it to me, that I'll accept it. After that, it'll be closed down and I will not accept it. So get it to me. I don't want any of you guys to say you're having issues with your iPads or whatever with technology, because you have plenty of time to get this done and get it to me. After Wednesday, starting on Thursday, or let's just say Wednesday after school. After Wednesday after school, it will be shut down. I will go in and turn off all the homework acceptance. And you'll have to show it to me And you'll have to do that during office hours because I'm not going to do it during class. And because I don't want to have to deal with, okay, your homework, this homework. So it has to be during office hours. Okay? So just be aware. After Wednesday, after school, it will be shut down. And you're going to have to get it to me some other way, and you won't get full credit. All right? So again, you'll have 3 days. It's going to be due Sunday, but I'll accept it up until Wednesday, and then I'll shut it down, and that goes for all my classes. All right? So anyway, I hope you all had a good Christmas, and I will talk with you when I see you. Bye-bye.